on last night's, was there any general questions overall about something that pertains to all of them? Not a specific problem, but something in general for all of them. Yep.
Well, some of the problems I understood the words part,
Yeah.
but others I had a hard time.
Alright, so for the words, coming with the words, I suggest starting with, like, on the third one, use the units. So if the units of the graph are kilometers and hours, and we're talking about a car, we're probably talking about kilometers per hour. And use the function to figure out, well, how fast.
Yeah, but I had a hard time to tell. It said it didn't tell how far you traveled. I mean, it didn't tell the time.
Yeah, you don't need that. It's not asking about that. It's really about how fast you travel.
So there would be nothing on the bottom graph of the time, right?
I mean, oh, you just start at 1 and go 1, 2, 3, 4. Yeah, you can just be in general. Or you can do skip do every other one.
Okay.
Yeah. So domain and range, get the graph done, and you can see what the domain and the range is. There's a lot of ways of saying this, but yesterday we did this on the example problem. So here the domain, you just say you could say it's like 0 through 4. And the range, all the numbers we picked were 0 through 40. 40 was the highest. So you can say everything is 0 through 40. And that's it.
Yeah.
So when you talk about domain and range, it's like the domain and range shared by both graphs. Okay. Or you could just list, like if you made a T-chart, you could just list all the X values and all the Y values for the domain and range.
Oh, back to number 3 really quickly. So for number 3, there would be no domain, correct?
No, yeah, the domain, you have to have a domain.
So you just make it up?
Yeah, we can say after 1 hour, 2 hour, 3 hour, 4 hour, and whatever your highest value of domain is, that's where your domain stops.
Okay.
For the problems, like the Mustang and Camaro one,
Yep.
and the Carmelo company, when they give you the actual functions, so do I write, like, okay, for the Jonathan Johnson Mustang as modeled by f of x, so
Yeah.
do I write 45x, just write next to that in the words, or no? And then how do I graph that? Or where do I
Remember,
start?
okay, so first the graphing, 45 is 45 over 1, which means 45 kilometers, because that's the rise, right? That's the vertical.
Yeah.
45 kilometers for every 1 hour. So that means over here you have to label these, pick a certain increment to go by, so you can go by 45s. And so it means up 45 kilometers for every hour, right? Just depend on what your scale is. Some people pick 30, just up to whatever you want to do. So just remember the meaning behind this. This 45 stands for 45 kilometers, and we don't put the over 1, but 45 kilometers for every hour, 45 kilometers per hour. And this would be 60 kilometers per hour. So obviously, since Camaro is going faster, the graph of the Camaro will be above to show that it's faster than the Mustang.
How do you want it, like, is there like a certain way that we can figure out how to label our y-axis? Like, I don't know if we start like 45 and 90 and...
That's up to you. You have to figure out what you want to do.
But it's just so there's no, like, particular...
Not really.
Okay.
No. But I can tell you what you don't want to do, and you can try to figure out why. You don't want to pick 10. Like go 10, 20, 30, 40, 50, 60, because then you can only graph 1 hour of the Camaro. After 1 hour, it'll be 60. And then if you try to go 2 hours, it should be at 120, but this stops at 100. So you're only using a little sliver of the graph, so counting by tens is probably not a good idea. You have to pick an increment that suits both of the numbers, both of the graphs. So after 2, this is why I suggested yesterday doing a T-chart for both, and you can see 1, 2, 3, 4. Okay, 45, 90, 135, 180, and then 60, 120, 180. You can say, well, these both have 180. Maybe I'll go up to about 200 here. If I want this to go 200, I have to count by this many. You know, if you went to 220, it wouldn't really matter. There's not like a perfect stopping point right here. That's just whatever suits the problem. So, yeah, in that sense, this can be a little bit more difficult because there's not this very clear one right way of doing it. So it's that age-old thing, like you might have come up with another way of doing a math problem before, and your teacher might have said, well, this is wrong because it's not my way. This is the opposite. I'm not telling you to do it a certain right way, and you have to be okay with that. And if you have a slightly different graph than somebody else, you have to be able to look at both and say, oh yeah, yours went up to 200, mine went up to 300. But it doesn't really matter as long as the functions are drawn right, it's still correct. Okay. So be okay with this multiple answer possibilities. Yeah. No.
How do I write it out in the compare box?
Okay, so the compare box. Question about the comparing that you want to use just basically everything I was just saying, but think about steepness and think about what does steepness mean for the particular problem. So like on the Camaro Mustang problem, a steeper line means a faster car. So don't just say, well, the Camaro's graph is steeper. You can say, well, since the Camaro's going faster, it's going to, going to be steeper than the Mustang or something like that. So just relate it to the problem. Or like on the first one, don't just say, well, what was it, Zane and Baylor. Don't just say, well, Baylor's graph is steeper than Zane, so that we can see that. But why? Well, since Baylor makes more money, the graph will be steeper because they're making more money per hour. So relate the compare box to the actual problem, not just generalities. So take another swing at this, finish up anything that needs to be finished up. We're going to do activity right now, and then once you finish that, there'll be time maybe for you to go back to this. And of course, the purpose of all this stuff is to get ready for your test on Friday.